Good afternoon, good evening, everyone. Thanks for joining today's session on Azure Automated Machine Learning. And Today we have Indira Bhandari, who is going to talk more about the topic. And she is a Microsoft Data Platform MVP and a data architect. And she is going to help us better understand the topic and how you can do the automated machine learning in Azure. Before we get started, that the session is going to be recorded and available in our YouTube channel, and there is going to be certificate of participation at the end. And that's all from my side, and moving the mic to Indira to get started with the session. Over to you.
Thank you. Thank you, Surag. Welcome everyone for my session on Azure Automated Machine Learning. Um, just a little bit about me before we dive in. I have a master's degree in statistics and I have been in the data field for over 20 years now. So, started off with Microsoft Stack, been in the BI space and data space, CRM customization, and mainly on the Microsoft stack. And now I'm working as a data engine, as a data architect in data engine. And I have this passion to teach kids all about technology, which I developed in 2016. So that has resulted in me floating a charitable trust, which is called Kids Tech Charitable Trust, which I use for training kids in SQL and Power BI. And some of the kids whom I have trained, they are running coding classes for younger kids, like 5 to 10 years old. So, which I think I'm proud of. Yeah, that's a little bit about me. If anyone wants to contact me, LinkedIn is my best um, way to contact me because my email is, I think, as of now, over 900 emails are there which I need to check. So, best way to contact me is on LinkedIn. It's Indira hyphen Bandari, and Bandari is not BH but BANDARI. Okay, now coming to today's agenda, we'll just cover what Azure Machine Learning is and what machine learning project lifecycle components are, and what are the Azure machine learning components that we need to know before we dive into the automated machine learning uh, experiment. Okay, now it's not just me who is going to talk. I just want to get some responses from you all as well. I just want you all to be interactive. So I just want to know who all are working in machine learning space. You can type in the chat or raise your hands, whatever. I'm just watching you. Just want to know the audience so that it gives me an idea as to, but not Azure ML. Okay, that's good. Thanks, Josh, for replying immediately. Waiting for others to respond. Data engineer. Okay, that's good. It's good that you are taking the next step to learn about machine learning. Mimi. Any others who want to reply or raise hands? No background or any experience in this field. Okay, no problem. Anyone else who has experience or don't have experience? Any response is good here. Same here. Okay, that's good. Web developer. Okay, good. Thanks, Ajay, Daniel, Lian. Lian or Yuan? Yuan, I think. Yeah. Any other responses? Don't have any experience. Okay, okay, AI. Uh, Ruiz, AI. What kind of experience do you have in AI? The background, so I don't have. That's okay. Data consultant. Good to know. Uh, Computer science undergraduate student. Good to know. Front-end developer. Okay. Doing ML course. That's good. Anupam. Don't have experience. Okay. I take it that most of you are fairly new to machine learning, uh, and that to Azure machine learning. I think only one couple of people, one person is doing a course and one person has ML background, but not Azure ML. Yeah. Today, what I'm going to cover is going to give you an idea as to how to get started with automated machine learning and also learn what Azure machine learning is. And I'm going to ask questions. So, okay, so today's agenda, we have covered the agenda, right? So let me go next to, okay, what is Azure machine learning? What do you think is Azure machine learning? I want you to answer before I tell you what Azure machine learning is. Can anyone, you can come off mute or you can chat. What is Azure machine learning? What is Azure? Machine learning being created and deployed in Azure platform. Very good. Yes, that's a cloud. Yeah, Azure is a cloud platform, right? So Azure is a cloud platform. And what could be Azure machine learning? Just a guess. What if it is a cloud platform? What happens in the cloud platform? Just think about that and then give your answers. You have a platform, and what are being offered in the platform? Training, deploying machine learning models. So in a way, it's a cloud service, right? Azure Machine Learning is a cloud service because it's a cloud platform. So Azure Machine Learning is a cloud service that is offered from Azure platform, and it will help in accelerating and managing the machine learning models or whatever the project life cycle, whatever happens, and helps machine learning professionals. You can have machine learning professionals, you can have data scientists, or sometimes even data engineers use it on a day-to-day basis to create and deploy models. Okay, so that's in a gist what Azure machine learning is. And now I'm going to show you what there are some components as part of the Azure machine learning that mm, there are some terms that you need to know. So Azure machine learning, because it's a cloud service, you need scalable compute resources. Is everyone familiar what compute resource is? What do you mean by compute resource? Can anyone answer? Making the machine to understand from past data and pattern and predict. Very good, Sanjay. Okay, VM. Yeah. Okay, Sneha, that's a little bit. You are close to the answer. So compute resources. What I the question is what is compute resource? So compute resource, the hardware and software components used for performing calculations. Yes, very good. Yeah. If you if you for example, I'm just thinking out loud here to how to best explain. You have all the, you are making a pizza, right? You are making a pizza. For that, you have the base, you have the vegetables, you have the cheese, you have the sauces, everything you have. So all the resources you have. But in order to make it as a pizza, you need something, right? You need a oven so that it cooks in the oven. So in this occasion, you think of the oven as the compute resource, so that oven will help you cook it and then transform the raw materials into a pizza. So that is what is, in a layman's term, compute resources. So it's an engine. Compute resource is an engine which helps you, whatever you are trying to do, it will help you to run the process or create a model, and then give you the results. So that is the example of what a scalable compute resource is. Hope you understand. You have understood what that means. So you need some, um, when you use the normal laptop or a desktop computer, you, if you are trying to run a program like C sharp or whatever you are trying to run, you can put the code, but once you put the code, you need something to run. So that is what is needed. So that is called compute resource. So Azure Machine Learning have scalable compute resources. What is scalable? Scalable means you can start with small. I need, let's say, uh, 24 cores of um, compute power, but then your program is requiring more. So you can scale that from 24 to, you can choose 48. If you choose auto scale, then you can, it automatically increases, and then when it is needed, and then comes back to whatever is initially configured. So that is scalable compute resources. And you have, in Azure Machine Learning, you have authoring tools. Very easy drag and drop designer is there, which is called the machine learning designer, Azure Machine Learning Designer. And I think my last topic in this session was Azure Machine Learning Designer, and the next one is today what we are going to cover. It is the automated machine learning, which is called AutoML. And the other one is you have you can create ML pipelines, and the other authoring tool is writing notebooks, Python notebooks, and creating the code, and then using the compute resources to create the models. And the bottom ones are, after you create the model, there are some processes that you can follow to deploy these models. So you can create machine learning pipelines, and then you can have model interoperability. I think there is a spelling mistake there. And then you can use MLOps. MLOps is nothing but um, uh, DevOps. I don't know whether some of you must have heard about DevOps for machine learning. DevOps for machine learning is MLOps. What is DevOps? Can anyone tell me? Is okay. The question, I can see a couple of questions here. Do you have a certificate? Yeah, you will get certificate if you are there till the end. One of the question that I am hearing is Azure machine learning different from machine learning? It is not different. Azure machine learning is a interface where you can do machine learning using Azure machine learning resources. So you can do machine learning outside of Azure as well. Azure machine learning is machine learning done in Azure cloud platform. There are machine learning that you can even do in Databricks, even Google Cloud platform or AWS platform. So I hope that answer is clear, Daniel. And yeah, development and operations. DevOps is very good, Deepak. Yeah, my question was, what is DevOps? DevOps is as Deepak is saying, development and operations. The word uh, DevOps was coined based on the development plus operations. So dev from the development was taken, op from operations was taken, and then the word was coined as DevOps. What do you mean by that? The meaning is you can deliver applications and services using DevOps. So for example, I'm a data engineer and I'm developing applications, and I need some process, some release management. So you are developing and you can't just put that into production, whatever you develop, right? There should be a process. You need to develop, and then once you develop, you need to test that. So there will be testers, or some users can test it, or there can be separate testers assigned to that to test that particular development. And from testing, if everything is okay, then it will go to production. Otherwise, you just have to again go back to developers saying that these are the bugs that are there in the application. Can you please fix it before we test it again? So that process is there. So that is called uh, the whole process is coined. The term coined is DevOps. Sneha, yeah, DevOps is an approach, yeah, that fosters collaboration between development and operation. Perfectly put, Sneha. Very good. Okay, so now, so that is for DevOps, that is development and operations. Now, MLOps is nothing but same process but applied for machine learning engineers. So, machine learning projects will have operations. So, you will have a development pipeline. Then, once development pipeline is done, they are promoted to a test pipeline. So, where the tests are done, if the tests don't make the mark, so they'll again go into the development as bugs, and then yeah, so that process repeats. So that is called MLOps for machine learning. So this is and a lot goes on in not only Azure machine learning but machine learning itself. So I just put a few of the things which I thought that you need to know. So coming to the next slide. Okay, what are the Azure machine learning components? So I will show you all these when I take the demo. But before that, what are the components? Components is you need to have an environment. So development environment or a test environment, whatever. You need to have an environment. And you in the environment, you create an experiment. And within the experiment, you will have pipelines, you will have data sets, because without data sets, you can't do an experiment, right? You need to have some data. And then without models, you can't do machine learning, right? So you have to have some kind of models. And also you have you when you deploy the models, you will have endpoints for which other data can be connected to the endpoints, and then the model results can be used. So these are the main components of Azure machine learning. Now, any questions so far? Yeah, DevOps is a support is it's a process. DevOps is a process, is a methodology where various tools can be used. That is that's the answer for that. Is it's not just tools, but it's a methodology that for which a lot of tools can be used. Okay, that's the answer for Nuria server. Yeah. Okay. Yes, you can run Python scripts as well in Azure Machine Learning, Josh. Yes. And Okay, so now let's go to the next slide. Machine learning life cycle. Okay, machine learning life cycle. Who can tell me what the first thing that you need for a machine learning project? What is the first thing that you need? Yeah, something sort of pipelines is CI/CD pipelines. Yeah, something of that sort. You need to create a pipeline to create the experiment. Yeah, which will compile all the compute resources and the models and will run it. Yeah, that's the pipelines. Yes, Sanjay, yes, that's right. Data. Okay, so you need a data set or data. So the first step is get data. So that's I hope you can see, I should have increased the font. Um, get data. So what's the next step? After you get the data, what do you do with in a machine learning project? Well-defined problem or question that the model is trying to solve. Very good. Yeah, Rubin, very good. Yes. Yeah, after getting data, you don't directly dive into model. Um, law, right? Yeah. After getting the data, you don't straight away dive into model. But Sanjay, you are right. Data cleaning is right. So yeah, so data prep, yeah, data prep is also right. Cleaning and pre-processing is also right. So the next step will be data cleaning. Yeah, data preparation, data cleansing, data transformation, all those things come in the same. And the next one is feature engineering. What is feature engineering? Can anyone tell me? In machine learning projects, you do feature engineering. What exactly is feature engineering? Anyone can answer. Extraction of features from the data. Yes. Addition, deletion, combination. No, that is combination data imputation to improve the data set. That will be part of Josh. That will be part of data cleaning and transformation. Okay. Refine features to solve XYZ problem. Selecting the attributes. Yeah, Swapnil, you are close. Selection of data columns of data set. Features that correspond to the output. Okay. Machine learning technique. That's very vague, Nuria. Okay, so I think selecting the attributes, Swapnil, that is correct. Selecting data columns, you are close, Anupam. And Sanjay, you are features that correspond to the output. Okay, let me give you an example. So, for example, I am predicting a car price of a car. Okay, I want to predict the price of a car, and I have a data set um, for the for predicting the car price. What are the features? What could be the features for predicting a car price? I'm trying to buy a car. What are the things that I'm going to see? So those will be the features. So you can have like the model. What is the model of the car? Make of the car. Sometimes you want only two-door cars. You are looking only for two doors, or sometimes you will be looking for four doors, or sometimes you'll be looking for two-seater. Sometimes you will be looking for five-seater or seven-seater or eight-seater. So those are all the features. So that is what is so choosing these features is called feature engineering. And the types of features you choose will affect the model. So that is one of the step uh, that you need to consider. Okay, so first is getting the data. Second step is data cleaning, transformation, data preparation, whatever you want to call. That is one. Next one is feature engineering. What are the features that we are going to use? Next step is model selection. So based on the problem, you will need to select the model, right? So it could be a regression model or a classification model or a computer vision model or a natural language processing model, whatever. Okay, so you can choose that. And any guesses as to what will be the next step after model selection? Seating capacity, yes. Talk, yes. Very good, yes. What will be the next, what do you call, next step? Training, data training, yeah. Model training. Okay. Okay. Before model training, I also forgot hyperparameter tuning. That also is sometimes you need to tune the parameters. So that is also another step, which is more predominant in automated machine learning. And then comes the model training and validation. And after that, you will have model deployment and prediction. So once you are happy with the model training and you have validated the model and you are happy with the model, that's when you deploy the model and for prediction. Okay. So this is a general machine learning life cycle. But there are some struggles with this one. What could be the struggles? Any constraints, struggles or constraints? Any guesses? With a normal machine learning project, what are the constraints? Yeah, splitting data, all that is there. Yes, you can do that. How low accuracy score, overfitting, yeah, and yeah, all that comes under this thing. Okay, so now, yeah, overfitting, underfitting, all that. But basic constraints are, um, for example, a machine learning, doing a machine learning project and training the machine learning project is a iterative process, right? You go back and forth from, let me go back. See, from data cleaning to feature engineering, this part you will be repeating. From data cleaning, feature engineering, model selection, hyperparameter tuning, and model training and validation, this part is a repetitive, iterative process. That's what I'm trying to get at here. And also, it's a tedious process, right? And also, sometimes, yeah, it's time consuming, and also there are lack of machine learning skill sets. People with machine learning skills are less compared to other skills, other data skills. So those are the machine learning life cycle constraints. So in order to overcome that, we can use the automated machine learning cycle. What what do I mean by that? So if we look at the same machine learning life cycle that we have done, first part is getting data, which is, yeah, that happens. That is a given. After that, the process that is iterative, that is repetitive, that happens automatically. All these steps happen automatically in the automated machine learning. That is why it is called automated machine learning. We will be seeing how it is going to happen automatically. Now, then after all these 1, 2, 3, 4, 5 steps are done repetitively, and when you are happy, then you will be happy with the model, and then model deployment and prediction will again, that will be the next step. So in automated machine learning, all these steps are automated. So that's why it is called automated machine learning. Okay, clear? Any questions? Yes, yeah, I will explain to, yeah, we will actually go through a demo so that it's easy for you to understand. So only theory you can't understand. Okay, somebody is raising a hand. Is that Josh? Yeah, Josh, unmute and please ask your question. Okay, I think the hand is lowered. Okay, let's get back to it. Okay, now, so this automated machine learning life cycle will solve those issues, right? So because it is automated, what will happen is, okay, let us see what automated machine learning is. It's called auto ML, and it's a process to automate the task of machine learning models. So of creating, sorry, task of creating machine learning models. Okay, it automates. And what is the automated process? Those five tasks will be automated. Okay, now the auto ML considerations are, there are some constraints here for using automated ML as well. You need budget, so you need to allocate some budget for running time, because now the hard work, instead of doing the machine those things manually, you will get the computer to do it. So you need to allocate budget for the running time, because it costs a bit of money in the compute resources. And also the next one is, yeah, memory. You will take a lot of memory, use a lot of memory in creating the automated um, ML project, which will use the CPU or GPU usage. So these are the auto ML considerations. And what are the benefits of automated machine learning? Because it automates the tedious tasks. So it is still time consuming, because but it won't take that long. Machine learning manually, if you do, it might take sometimes weeks, depending on the model that you are creating. Sometimes weeks, sometimes months even, because you need to get the at least 90% accuracy or 80% accuracy. If you that is your benchmark, then it will take some time if you do it manually. But automated, the auto ML, it won't take weeks or months, but it will it will reduce the time by maybe, yeah, 3 hours or 6 hours, depending on your problem and depending on your data and all those things. So but it automates the tedious tasks where you need to do feature engineering, where you need to do hyperparameter tuning. All that is automated, so which will increase the efficiency. And also, because it is automated and done by the computer, it solves the lack of machine learning expertise. But you still need machine learning expertise to analyze the models that you have created, so you still need that kind of skill. Okay, so those are the benefits of automated machine learning. Now, what are the automated machine learning capability in Azure? So what kind of models can you create? What I mean is, what kind of models can you create? So you can create regression models, you can create classification models, you can create time series forecasting, and you can create image classification using computer vision, and also you can create natural language processing, NLP. Okay, so these are the 5 capabilities. And can anyone answer, is apart from Azure machine learning, can anyone answer whether there is any other tool that you can use in Azure for machine learning that you can think of? Apart from Azure machine learning. TensorFlow. TensorFlow. Yeah, it's an open. Yeah. TensorFlow. Yeah. Uh, yeah. TensorFlow. You can use it in the notebooks probably. I'm not that familiar with TensorFlow, but what you can do is, yeah, Python R are tools, are languages that can be used in when you are creating the notebooks. What No, Power Automate doesn't help you in machine learning. One other tool that you can use in Azure is Databricks. Databricks is a tool which supports machine learning. So you can create machine learning models using Databricks. So Azure Machine Learning or Azure Databricks can be used. So that's the answer I was expecting. So anyway, yeah, scikit and all these are libraries, Python libraries, so you can use them as well. But yeah, in terms of tools, you can use 2 tools for machine learning in Azure, which is Azure Databricks and Azure Machine Learning. Okay, so now next one is, okay, before we dive into the demo, you need you need to think of these prerequisites. One is, you can sign up for a 12-month free subscription if you are creating a new account. And the new account should be created with a work account, work email, or a student email. So that student email should not be a Gmail or Yahoo email, but it needs to be, at least here in New Zealand, you get when a student joins the school, you get a email which is not Yahoo or Gmail, but for example, if you join a school, you get the school's domain as the email account. So you get a separate email. So that student email can be used to sign up for a 12-month free subscription. And so once you go into you create a resource under machine learning, you will get the option to start with a free trial. So then you can select that, and then that free trial will run for 12 months. So those are the 3 prerequisites. Now let's dive into the demo. Okay, so for the demo, you need to go log into portal.azure.com. So I will share my screen again, I think now. Question. Microsoft 3 E5 license. I think you can create, you need to have a Azure subscription, not M365, but you need to have a Azure subscription. Yes, somebody. Shabiha. Yeah, what's your question? Can you can unmute and ask? Yeah, thanks, Josh. Okay. Shabiha, what's your question? I can't hear you if you're okay. Looks like you can't unmute. So do you want to put your question in the chat? Yeah, put your question in the chat. I'll come back to it later. Okay, now let's go to portal.azure.com. I'm going to use my MVP account. And okay, so portal.azure.com is for all newcomers for Azure. Azure is a cloud platform, right? So this is the platform. So portal.azure.com is the platform. And in this platform, you have lot of services, and Azure Machine Learning is one of the cloud service. And you have all the other services like Azure OpenAI is there. You have storage accounts where you can store some data, some files and things like that. A lot of services are there. So for example, if you click on create resource, you have lot of resources. So now let's create a machine learning resource. I'll start with the basics, even though I have created earlier. I'll start with the basics. So because I need to create a machine learning model, it's easy, so intuitive. So I need to create a Azure machine learning resource. So what I'll type is I'll just say machine learning and then choose this one. So it is looking in the marketplace for all the all the services that are offered on Azure Marketplace and then getting the results. What I need is Azure Machine Learning. So that is the service I need. So I'm just going to choose that service. Now it's very easy to do to create a Azure Machine Learning service, as you can see that there is a create button here apart beside the Azure Machine Learning. Okay, so I'm just hitting create. That's all. I'm not thinking anything. Just chalo. I am just creating the Azure Machine Learning resource. Okay, now for creating this resource, as I told you earlier, you need a subscription, you need a resource group, because you consider this as a let's say a folder structure. You will have, let's say, documents. Uh, Under the documents, you create a folder called Azure Machine Learning, something like that. So subscription is a high level container, and within that subscription container, you can have different resource groups. So my subscription is called Visual Studio Enterprise. I don't have any other subscription. Just Visual Studio Enterprise is my name of the subscription. And I want to create a new resource group. And the structure is like this. You have a subscription, you have a resource group, and underneath the resource group, you will have all the resources. You can create one resource group for Azure Machine Learning, you can create one resource group for each of the services that you want. So I'm just going to create a new resource group. I'll just say AutoML RG. RG stands for resource group. So I'm just going to create that so that my cleanup of resources will be easy. because if I just delete the resource group, everything underneath that resource group will be deleted. Like how you have the if you have a folder underneath documents, if you clear, if you delete that folder, everything underneath that inside that folder gets deleted. So that is the example of the folder structure. So you have a subscription, you have a resource group, and I'm just going to create a workspace called AutoML workspace. AutoML workspace region is I'm close to Australia East. New Zealand data center is not yet there, I guess. I haven't seen. So Australia East. Okay, I'm choosing Australia East. You can choose whatever is closer to your region. And I'm just leaving these two blank. These not blank, these two defaults. It creates a storage account because Azure Machine Learning, because you are going to store data sets, right? So for that, storage account is needed. So by default it creates the storage account. And if you are storing some passwords, you can store that in this key vault. So that is key vault and storage account are automatically created. So now you can see these tabs. Networking tab, you have encryption. Okay, let's go next. Networking. At the moment, I'm keeping everything public because I don't want to go private with internet outbound and approved outbound. I just keep it public. And encryption, I'm just keeping it as default. And identity, just leaving it as blank, but these need to be configured if you are creating enterprise ready models. Okay, but if you are just practicing, just keep it everything simple, and you can review and create. So in the review, you are getting what is the subscription that is being used, what is the name of the resource group, whether it's new or existing, region, name of the Azure Machine Learning workspace that you are creating, storage name, storage account name, key vault name, application insights is also being created. And then container registry is none because at the moment we don't need it. Now I'm happy with the with all the summary that it has given. I'm just creating it. So first, what we are first step is to create the Azure Machine Learning. You can say workspace. So environment. You are creating the environment. Remember, you have seen the in the PowerPoint. You have seen the components, Azure ML components. One is the environment. So this one is you are creating the environment for all the resources that you need. So now it is creating. It takes a couple of minutes, and once it is created, yeah, deployment in progress. Once it is created, you will get the um, yeah, just that part is getting created, and once that is created, you will get the notification as deployment succeeded. Um, any questions? Let me check whether there are any questions. Certificates, I found Azure only free. You credit and then will change. Will charge. Yeah, after 12 months, you will get charged. But for that is only for some services. Other services are chargeable. So okay, now the deployment is complete. So I'm just going to go to the resource. Once I go to the resource, see, this is showing Microsoft Machine Learning Services. Okay, so that is what it is showing. Now, if you see the overview, this is the resource group, this is the location, this is the subscription that it is using, there is a storage account, the URL is there, Key Vault, application insights, and ML flow tracking URL also is there. Now, underneath this one, you have something called Launch Studio. So this is where you will develop the machine learning model. So I'm going to launch the studio. It launches in a new tab. Hope everyone can see the tab, right? Okay. So now, excuse me. Okay. Now in the when I first introduce the what is Azure machine learning. I mentioned that uh, couple of authoring tools. What were those? See, this is the authoring section. There are four authoring tools. One is the designer, which is a drag and drop interface, which I covered in my last session with the Java. Now, so you have your machine learning designer. So, for example, let me just check whether I can show you something. Okay, maybe automobile price prediction. So I will just show you that how it looks. See, it looks like this, drag and drop. So you select your components here, automobile price data set, or sometimes you can say select columns. You say select columns, you will get the components here, and then you just drag. So this select columns in dataset has been dragged here. So this is the model creation process using designer. So this is the dataset. Remember this life cycle dataset. This is the selection of columns. That is the sort of feature engineering and data cleaning process. After data cleaning process, you will select the model. So select the model, and then you will prepare the data for uh, using for training and testing. Here you split the data into training and testing data sets. So you use the trained data set with the model. Here the model that has been used is linear regression model, and then you train the model, and then once you train the model, you score the model, and for after scoring the model, you use the you use the test data set for scoring the model. So this is the test data set, and that's the trained data set, and you will evaluate the model. And once you evaluate the model, you once you complete this designer phase, you run the see this pipeline. You create a pipeline interface, and then you run the experiment. Once you run the experiment, if you are happy with the model, then you do the deployment. So that easy. It's that easy in using designer. Now let's go to automated ML. And you can also use notebooks as well. I'll just briefly cover that. So you can use create a new notebook, or if you already have a notebook, you can also import that notebook here, and then you can start modifying that. And here, remember I said scalable compute resources. So you need to create a compute for that. Okay, so now let's go to automated ML. Since time is not that. Okay, before that, I have a data set which is called, let me just check what, yeah, it's called by number. It's in a CSV format. It looks like you can't see it. Okay. Here, what I'm trying to do is using this automated ML. Um, I'm trying to create a forecast. I'm trying to forecast the demand um, for bikes. There is a company. There is a company that let's say there is a fictitious company, and they have a data set where they have data for um, bike share. So they give bikes for rent. So what is the demand? I'm trying to forecast the demand for this bike rental company. So for that, what we need to do is, first thing what we need to do is you can start with this step, the new automated ML job. So I'm just going to create that. So and then I'm just going to give a name called let's say auto ML job. Okay. And experiment name, I'm just trying to create new. Can I create? Yeah, it's create new. You can name the experiment as auto ML EXPT, and you have a description if you have this, or whatever. Yeah, whatever you want to shop or something like that. Whatever you want to add in the description so that it's clear for you. Once you add this basic job name and experiment name, then you click next. Once you do that, what this shows is, because the first step is to get the data, right? So that's what we need to do now. First of all, we need to we need to choose a task type. What are you trying to do? What are the task types that are available in Azure, automated Azure machine learning? We have gone through these. We can do a classification model. We can do a regression model. We can do a time series forecasting model. We can do an NLP and computer vision. Today, I'm going to do time series forecasting because I have a relevant data set that can be used for this one. So here, what you need to do is you just create, because in this select data, you just create the data set. And I'm just going to name the data set as AutoML bike data set, TS. If you want, you can do the description. And here in the type, you can choose whatever is relevant. I'm going to choose tabular because it's the data set that I have is a CSV data set, which I'm going to show you shortly. And I just hit next. And then from when I say next, you can either choose from Azure Storage or SQL database or a web file or Azure Open Datasets. You have a lot of open datasets, but I have downloaded it in my local file. So I'm just going to choose from local files. Once you choose that, the next becomes highlighted. So you just go next and then choose the um, okay, because remember you have the blob storage that gets automatically created. So I'm just choosing that blob storage and then I'm just going to go next. And here you can upload files or folders. So I'm just going to upload the file, which is named as bike number, and then hit next. So uh, this is the preview of the file that it has. So there is a date for time series. We need a date, and it has season, year, month, weekday, weather, all these kind of features. Weather, yeah, weather, temperature, all these things are there. Humidity, wind speed, casual, all these things are there. So now here I need to make sure that I have the correct settings here. So delimited, because I have a CSV file. So it's a delimited file format, comma, separated. So delimiter used is comma, and then encoding is UTF-8. Column headers, you can actually choose all files have same headers or only first file has headers, because I'm just uploading one file. So I'm just choosing that. And then if you want to skip rows, you can skip rows, but I'm not skipping rows. So I'm just going to go and and if your data set contains multi-line data, you can tick that as well. For now, I'm not doing anything. So I'm just going to go next and then just create the file and then just going to create. Next one is okay. So now that is created. Okay, success. Now the next step is I'm just going to choose that AutoML data set that I have created. And the next, so there are three steps that we have finished. Next step is task settings. What is it? Oh, I need to go back. What is the task setting that I am doing? Because we have already chosen, right, time series forecasting. That's good. Okay, now here, if you hit next, we have to go through the settings for the time series forecasting. So what are the things that we are going to do? For time column, we will choose the date, and auto detect Time series identifiers, I'm just going to leave it as blank. And auto detect frequency, maybe I can use that. And then auto detect forecast horizon. Uh, I will change that to not auto detect. And then um, yeah, forecast horizon also none. And then here, view additional configuration settings. That's what I clicked here. Okay. So here primary metric is normalized root mean squared error. That is the metric that we are going to choose. And we want to explain the best model. And I'm not enabling the ensemble stacking, and um, use all supported models. And one of the model that I want blocked is extreme random trees. You can block any number of models, but for this, I am just blocking extreme random trees. And here in the additional forecast settings, auto detect forecast tags, I'm just going to untick, and also auto detect target rolling window size, I'm just going to untick. Just do it as none, and then I'm saving this configuration for this particular job. Once that is done, uh, keep the validate and test defaults. So it is k fold cross validation, and number of cross validations. You can keep it as maybe 3 or whatever you want to keep. So maybe I'll just keep 3. And test data, we don't have any test data because that process will get automatically done. Okay, so now, okay, this is target column is also important. So I'll just put target column as we just count. Oh God, I think this has gone back to auto detect frequency is okay, but auto detect forecast horizon, yeah, and okay, again it went to something. Time series identifier. Hmm. Forecasting, auto detect window size. Um, yeah, these are all okay. Save. For some reason, next is not coming. I'm just thinking why. It's going to number of cross validations to use to assess the results. Okay, fold is the right one. Um, maybe let's say 5. Why is the okay, target column is instant. That's what I chose. Auto detect time series. Yeah, we don't want auto detect time series identifiers. And yeah, auto detect. Okay, this is what is causing it. Okay, let's keep it like that and then just go next. And now here is you are defining the compute, because the automated machine learning should use some compute resources. So for that, in the select compute type, you use compute cluster. And then you can create a new cluster because there is nothing there. And here you can choose dedicated CPU, and you can choose this 24 core one, or you can choose the memory optimized. I'm just going to choose general purpose for now. And you will get the cost also here, 24 cents per hour and 40 cents per hour. And yeah, go to next. And then now here you give a name, auto ML compute. And you can leave minimum number of nodes as 0 because when the compute cluster is not running, you are not charged. So I'm just going to leave that there. And you can increase this one to maybe 5 or 6, but I'll just leave it as it is for now. And then I'm just going to create the compute cluster. So once that is created, oh, it's almost time. Okay. Any questions so far? Which feature is suitable? In automated ML, what happens is feature engineering is automatically done by the automated ML process. So you don't have to choose which features. But that is the difference between normal manual machine learning and automated machine learning. So when you are doing machine learning using the designer, then you need to do some experiments. If I include these features, what is the result of my model? How is my model performing? If I exclude one of the feature and include only 4 features instead of 5 features, what is the result? So those kind of things you need to do a trial and error and see the performance of the model and then decide. That's why it is time consuming when you do a machine learning model manually. Hope that answers Noria. Yeah, can I use multiple models? Yeah, that's what I'm going to show you now. Okay, so now the compute cluster has been provisioning is succeeded. So now we can choose that. I'm choosing that compute in my automated ML job. So automated ML job, I'm following these steps. And the last one is when I hit next, it will be giving me a review of what my automated ML job uh, contains. So the name is this, experiment name is this, and what is the task type? I'm trying to do a time series forecasting, automated data, and yeah, all these validation. What is my validation type? Number of cross validations is 5, and all these things that it's going to show me. If I'm happy with that, I can just go submit training job. Once I submit the training jobs, it starts it starts to train. Okay, now I'm not going to submit this train job because it's going to take a lot of time. What I will show you now is in my um, machine learning. Okay, I'll again launch this studio. It will launch in a because I have created a similar job a couple of hours ago. Now it's 9 o'clock. Yeah, 6:30. So 1.5 hours ago. Now it's 2.5 hours ago. So I'll just show you quickly because time is up. Just show you quickly how that shows. So once you create the job, submit this training job, what will happen is it goes and sits in this job in the studio. It goes and sits in. You can access that job from here. Okay, and here you don't have any experiments. You have all jobs. If you go to all jobs. um, Okay, this is in this workspace. I don't want this workspace because I have created that in a different workspace. Okay, so I have created in, I think, AML 10, TBD workspace. Okay, that is the workspace I have created 2.5 hours ago. So I'll just go into that workspace, and inside that workspace, if I go to jobs, there are 2 experiments there. You can all see, right? There are 2 experiments. One is the automated automobile price prediction regression, which I used. I think I showed it uh, to the same audience on October 16th. And now we are going to see this job. So let's go to that job, and then it has Now the status is completed. Earlier, when I saw it was not completed, it was running. So it started on December 19th, which is 6:24 p.m. I think you are all maybe 7 hours behind me. So if you are all from uh, Asia, so um, f- so it took me how much time did it take? Yeah, duration is 48 minutes. 48 minutes it took for me to for this job to run and complete and check the models that using the automated model. So this is the summary of what that has given, that has happened, that the job summary. And if you go to the data guardrails, it will give you what times, what is the uh, time series ID detection, and then what is the description, whether it is passed or fail, and things like that. If it fails, then it will give you a red, otherwise it's a green tick. So all the data guardrails have been passed. And then here, if you click models and child jobs, this is where you will get all the models that were run automatically. See, all these models were run automatically against the data that I have submitted. And it is giving you the top model. Top model is um, this sorted by normalized root mean square error. And then top model it is giving is voting ensemble. And there are some, if you want to explain model, I think it will explain. Yeah, I'm not going to go into that, but yeah, that can be a different session. But this is how you can create a automated machine learning model. And this can be in what I would suggest is you can use this automated machine learning to come up with what are the maybe top 5 models that you would want to consider when in your machine learning journey while creating the model. You don't need to automatically take that and deploy. If you are happy with the model that is created um, by this automated ML, then you can straight away deploy it. But if you are still not happy and if you want to try your own feature engineering and hyperparameter tuning, you can do that. But you can at least utilize the models that it has identified as the top 5, and then um, do your hyperparameter tuning and feature optimization using those models. So that is where it can be useful. So that's what I wanted to share with you today. So hopefully everyone has learned something. And if you have any questions, please let me know. If you want to connect with me, you can connect with me on LinkedIn.
I think we are in wrap up time. So if you guys have any quick questions, please do drop it in the chat box. Let's wait only 1 to 2 minutes, and afterwards we will be winding up the session. So I shared Indira's LinkedIn. If you any of you want to connect with her. Okay, thank you everyone for joining. I will also share the certificate link of the today's session so that you can climb it right away. Also, there is some questions regarding the AutoML, which you can try out if it's something that you think you want to try out. Uh, these are some 10 questions related to AutoML, which is really basic. If you guys want to try out, go ahead and try it out. Uh, that's all for today. There is no more questions popping up in the chat box. Uh, that means we are good to go. Okay. Thank you, everyone, and thank you, Indira, for joining with us and taking your time to share the knowledge. And I can see that everybody was happy with the session, and we were able to interact with them as well. It was super interactive. Um, and yeah, looking forward to have you in another session next year also. And thank you everyone for joining, taking your time to learn something new. I hope you got something from this 1 hour, and please do try it out yourself, and so that it's more solid. That's it from my side, and thank you everyone, and have a great rest of the Wednesday.